Alright folks, today we're going to talk about the red Pitaya. For 300 bucks, probably the best HF exciter spectrum analyzer 2-channel scope that you can buy. Quite simple. What I got is the STEMlab 125-14. You want to get the 14. The 14 means 14-bit DACs and A to Ds. Don't get the 125-10. That means 10 bits. The more bits, the better. I mean, we're not going shitty here. If we were going to do that, we'd buy a hack RF or something. But this is a very clean HF signal generator, spectrum analyzer, and scope for 300 bucks. I mean, you just cannot get a more clean signal than what I've seen from this unit. That simple. Where'd I get it from? Just go to Mouser Electronics, put in STEMlab 125-14. I'm sure other places have it, maybe DigiKey, but I got the starter kit. It comes with the red Pitaya, the already made micro SD card, power supply, Ethernet cable, basically everything you need to go to get this thing started. It's that simple. Again, make sure you get the 125-14. The 14 stands for 14 bits. So you want to get the higher bits, is always better. Alright, like I said, the kit comes preloaded with the SD card. You just pop that in the thingy here. The card goes in upside down, but you'll see it when you get it. And this is the red Pitaya here. Basically, you got two digital outputs right here, 2 DACs, and these two guys are 2 ADCs. And all 4 of these things are running at 125 megahertz. So basically that's 0 to 60 megahertz signals, each at 14-bit resolution. I mean, really, really good stuff. How to get it going? Well, it's pretty simple. I just plug the Ethernet cable directly into an Ethernet port on your computer. Hopefully my laptop has an Ethernet jack that I don't use, so I just hooked it right in there. But any desktop, it's just find an open Ethernet port and plug it in, and then turn on power. It's really that simple. I will say here there's 2 micro USB ports. Make sure you plug the power into that one. This one here is a console, so you do not want to plug the power into that. So when you're powering this thing up, just make sure you plug it in there. That's the power port. Okay. Alright, so now you got it plugged in. You got the Ethernet cable hooked up. How do we control it? Well, very simple. Bring up Firefox on your computer there, or generally any standard web browser I think will work. Look on the red Pitaya itself. It'll have this kind of RP number thingy. This will not be the exact number for you. You're going to have to look at your own red Pitaya to see what it is. Anyway, just type this in up into your web browser just like that. Hit enter, and then you'll be directed to this web page here, and you can see all the apps that it can do. So we got a spectrum analyzer, we got oscilloscope, and signal generator, 2-channel here, 2-channel spec in as well. Got a logic analyzer, an LCR meter for measuring inductance, capacitance, and resistance. Alright, you can also click this marketplace thing, and that will let you find other apps that other people have created. But the predominant ones that I've used are these 2 guys right here, the spec in, the scope, and the signal generator. There's also stuff online to use the Skippy thing, so you can have like MATLAB or Python control this. If you want to automate something, right? You're not into GUIs, you just want to run MATLAB scripts or Python scripts, it can do that by the Skippy interface. Again, folks, for 300 bucks, this is just a win-win. You're getting basically a 2-channel scope, a 2-channel signal generator, or a 2-channel spectrum analyzer. And I challenge you to find anything better for that price point. I mean, why buy a hack RF when you can actually get a quality piece of gear here? Anyway, did I say that out loud? Anyway, off topic. Okay, for the scope here, The scope or the oscilloscope has two settings, what they call low voltage mode and high voltage. So you just move these jumpers around to set which one you want. So in this case, they have channel 1 set to low voltage, so that means the signal's got to be within 1 volt to -1 volt. Okay. Here on channel 2 of the scope, they got it set to high voltage, so now this guy can now accept 20 volts to -20 volts is the range. All right, pretty simple stuff. And here's the GUI here showing you the scope. Again, this is all just through the web browser. You know, it's all just a web interface. It's really that simple. It's not that hard. It also has like I said, two channel signal generators that can make a frequency anywhere from 0 to 60 megahertz. Max power I've seen is about 10 dBm. You can just change the amplitude, knock this down to -20, -30 dBm, whatever you need, but more than enough power to drive some LOs or test some filters, test some HF receivers, whatever you want to do. Test some loops, tuning loop antennas, measuring amplifiers. I mean, you can. This is literally a electrical engineer's Swiss Army knife toolkit. It's amazing to me how colleges are not buying this thing, but you know, I guess I shouldn't be surprised when you got a bunch of stuffy, grumpy old college professors that, you know, don't know any of the new technology, and I guess that's why they're teaching. Anyway, let me get off topic here and get back to what I'm talking about. Here's the two-channel spectrum analyzer that this shows as well. The max signal for that is 10 dBm, and again, the frequency range is anywhere from 0 to 60 megahertz. And it's a very clean spectrum analyzer because it's literally a direct sample. There is no mixers anywhere in this device at all, folks. It literally is DAC to output, input to analog digital converter. That's it. Maybe some simple filters, some op amps, but there is no heterodyning or mixers involved here at all, which is why they can have such a large range, be pure of all the harmonics and mixer intermod products, because there is no mixer. Isn't that amazing? Bottom line, just get one. I mean, 300 bucks, just buy it, or tell your school to buy it. It's that simple. And stay tuned here. I'm going to start working on getting this red papaya to work with gnu-radio, in particular to make it a HF exciter. And I've got most of it working. I just want to finalize how I got it up and setting, because it was somewhat cryptic and a pain in the ass. But anyway, now that it's working as an HF exciter, it is the best HF exciter, period. It is an all digital IQ modulator, folks. There is nothing being done analog here. It's amazing. And this exciter can go out to 10 dBm for a frequency anywhere between 0 to 60 megahertz. Literally anywhere. You can put an AM carrier at 27 megahertz. You can put an AM carrier at 3 megahertz. You could put 2 AM carriers with images in the waterfall once you finalize all the IQ. This thing is literally an IQ streamer from gnu-radio. It's also an IQ receiver as well. It streams the IQ back into gnu-radio. And there's a couple people that have worked on this, but I don't know how this is not advertised more, but anyway, this thing with gnu-radio makes a very, very powerful HF exciter. An HF receiver as well. Personally, I think there's better HF receivers out there in the market that are more dedicated for that. But for the exciter side, folks, this is literally what's in your Anon, okay, that you're dropping $4,000 for. This is literally what's in your Flex radio that you're dropping $7,000 for, okay? This is literally what's under the hood of those modern HF transceivers. So just go out and buy one, and I'll walk you through the videos and how to set this thing up. I mean, 300 bucks, Christmas is coming around, maybe Santa will get you one, all right? Just go buy it. It's a great device for ham radio, electrical engineers out there, colleges, STEMlab, you name it. go out and buy the red Pitaya today. In particular, the 125-14. All right, folks, that's all I got. 10 minutes. Thanks for watching, and have a great day.